This is an update to a project I started a while ago, installing a solar powered irrigation system in the polytunnel on my allotment. This is the basic system laid out. There's a power supply, a piezo crystal, a 9-volt battery, and a breadboard with some bits and pieces on it. Let's look at the circuit diagram. Starting on the left then, there are two wire sensors which you put in the soil. That forms one resistor and a potential divider with a resistor above it. That feeds a variable voltage into the analog to digital input of a microcontroller, which then decides whether or not to turn a servo motor on to turn a tap to admit water under gravity pressure to the thing that's being fed. There's another potential divider with a potentiometer there, which allows you to set the level at which you want to trigger the watering. So there's that, and then there's a piezo crystal, which is the means that the system uses to communicate with you. Broadly, it beeps a number between 1 and 10 to tell you how moist the soil is, and then it bleeps another number between 1 and 10 to tell you the level of moisture that you set using the potentiometer. And when the soil is drier than the level you set, the servo is operated once per cycle, which can be anywhere from 30 minutes to a few hours. This is the business end. A servo is operating a ball valve which connects a water butt to the irrigation system. Taps on, the water flows, and so on. A couple of weaknesses in that system. The first one is that the servo has to work very hard to turn the ball valve on and off. I had to use metal gears, and even then it was a problem. Current drain is a problem. And the other problem with the ball valve is that it's very easily clogged with leaf debris or anything like that. So the system was unreliable, and you can't afford to walk away from a system that's watering a large polytunnel if you can't trust it. So it wasn't deployed. What's changed is really the servo, which was the cause of all of those problems. I replaced it with a pump. So rather than using the servo to turn a tap on and off, I used the microcontroller to turn a pump on and off. That pump's got a filter on the end, and in any event it's not a finely engineered ball valve, so it doesn't get clogged so easily. Well, okay, let's take a look. The plumbing side of things, the submersible pump pumps water up the green pipe and down into the black pipe, and the first thing it meets is this point here, which is higher than the water level. That's deliberate, and there's a tap here which is slightly on. What this means is when the pump stops pumping, well, when the pump starts pumping, this will dribble, but when the pump stops pumping, this will destroy the siphon action, which would otherwise threaten to empty the water butt and drench the plants. So that's what that's there for. And then a series of other T-junctions, which you can see here, going down to taps which are there to adjust the water flow to make sure that each plant gets the right amount. And the rest of these are kept under stones just to make sure that they don't fly around. Another one, and another one. So let's see the system in operation. It's on, but I've set the moisture level to 9. Let's turn it to something where it's guaranteed to come on. Okay, there's the dribbler, and then the water is coming out of these taps here. That one's not coming out very much, so that needs adjustment. And it all works very well. The system runs from a 12-volt lead acid accumulator, which is charged directly with a small solar panel attached straight across it. That's been stable for a couple of weeks, and we've been harvesting fruit ever since. So it's a success.